The purpose of this video is to demonstrate several technologies. One, putting numbers in hexadecimal format. Two, displaying things as a binary array. And three, indicating how you would sequence a set of things, which is something that very often has to be done in data acquisition or in user interface design. So, as usual, we are going to go with LabVIEW, but perhaps we ought to start it up first. Here we have LabVIEW 2015, and we will do the new VI sort of thing. One thing that you can do with the windows, if you are interested, is you can actually tile them, and maybe we will tile them left and right so that we have the two of them and can look at the two of them simultaneously. So let's see, what is the first thing that we want to do? Well, we want to be able to enter a number in hexadecimal. So unusually we will start on the front panel this time, and we want to put in a numeric constant, so we will put in a constant here, and we will call this hexadecimal input. And we have very definite ranges on this hexadecimal input. So we are going to play around and set a few things up here. First of all, we are going to go to the representation, and the hexadecimal representation that we want is an unsigned byte. We want 8 bits or 2 nibbles, if you will, because that is the size that we want. We want it unsigned so that we don't have to worry about signing when we do that. So now we can put in numbers between 0 and 255 on this, but it doesn't currently display as hexadecimals. For example, if I put 255 in there, it is quite happy with 255. If I try to put 256 in, it will take it down to 255 because that exceeds the range of the input that you can put in. So now we probably ought to do something with the display format for this. What sort of display do we want? Well, let's see. We've got floating point, scientific, automatic formatting, SI notation, decimal, and hexadecimal. Okay, so if we go, we want it as hexadecimal, and click OK, then now, it changed to FF, so we can put anything from 0 through FF in there, and there's our hexadecimal input. We probably want to see if we can get the thing to display as an array of something. So let's see what we can do. What would make a good binary indicator, and what would make a good array? Well, let's see. Let's go here with arrays, and we will have an array here, and we'll call this binary of input. And we want something that would make a reasonably good indicator for that. So if we go here, the Booleans look promising. A round or a square LED is probably good enough, so we will put that in there, and that gives us a total of 1 of them. If we want 8 of them, 2, 3, 4, 5, 6, 7, 8. If I can count, that should be correct. So now let's see if what happens on the block diagram. We'll just connect the hexadecimal input to the binary input. That doesn't look good. I wonder if there's something that could give us a binary array. Well, let's see. Let's explore around a little bit and see what we can find. How about in numeric? They have conversions. And here we have something called Boolean to 0, 1, and here is Boolean array to number. Here is number to Boolean array. That sounds like it might be a really useful thing to do. So we'll take a number to Boolean array and see if we connect that between these two, if they'll be happy. number, and Boolean array. Everyone seems happy. So let's run it and see what happens. FF works. 0, 0 works. So let's try F0 and see if that works. And you can do lowercase f as well. Does that look right? Oh, I would expect that this would be my least significant bit here, and this would be my most significant bit here. In fact, I might even want to indicate that on here. So I'm just going to do a little label and double click there and go MSB. So that's my most significant bit, and my LSB down here. So now I have my indicator labeled, but it seems as if there's something wrong. Let me try something like, let's see, what is 80? What should 80 look like? Oh, well, it should be the exact opposite of that. I wonder if there are any tools that are useful on arrays. Let's right-click on the line here and look in the insert and see if there's something on the array palette that might be useful. How about reverse 1D array? That seems to me like it might be really useful. Let's try that. Looks good. Let's try 8.1 or 8.2 and see if that seems to be working. And so, yeah, okay, so there we go. By reversing the array, we have our display behaving the way that we want. That was a good start. Let's see where we can go from here. Well, we want this thing to keep operating until we tell it to stop. The best way to do that is typically with a while loop, and there are a couple of different sorts of while loops that you can use. The one that I think is going to be the most useful is the one that is called, let's see, it doesn't show up there. There's the normal while loop right there, but I'm lazy. So I'm going to go down to my express VIs and go to my execution control, and I'm going to use an express while loop. Why am I going to do that? Well, let me put it in here and then we'll see if we can figure it out. Okay, what it did was it automatically put a stop button in there, and you can see my stop button displayed very nicely here on my block diagram. So I can make that stop when I desire. And one of the things that's sometimes useful is to be able to use a key to cause something like that to happen. So let's go here to properties and see if we can do something useful with this. And we'll go to key navigation, and we will go with the toggle, and we will toggle it with the end key like that. And so it should run, and then if we hit the end key on the keyboard, it should stop. So since I'm doing keyboards, I'll hit Control Run. It's running, and if I hit the end key, it stops. That's sometimes useful if you don't want to have to click the end key. Okay, well, that didn't do terribly well, and if because we have a sequence of things that are supposed to go on here. So let's see what we can do. What can we do? First of all, let's look at some timing things. If we want this loop to update on a somewhat slower basis, let's see if we can find something useful. This timing block looks useful. How about wait? Hurry up and wait. Okay, let's create a constant here, milliseconds to wait. Create a constant, and if we put 3,000 milliseconds in there, that's 3 seconds. And so let's try running this and changing the numbers, see what happens. So let's change the number there to 55, and nothing happens for a while. If we wait for 3 seconds, something happens. For 3, Okay, FA. Okay, then we'll hit our end key for stop, and wow, it takes a while to end, but it does eventually end. Okay, so we have our way of controlling things. We now need to do some sequencing and see if we can do this how we want. One of the things that we are going to need is we need an LED to flash that says the answer is coming up. So let's find us a nice Boolean LED. The square LED there looks good, and we'll call it answer coming up. Okay, so we've got answer coming up here, and it has shown up here. So let's see what we can do. For the moment, I'm going to pull these out of the while loop, and I will stick them in just a moment, because I want to stick something else in my while loop. And what I'm going to stick in here is a sequence structure. There are flat sequences, and there are also regular sequences. Let's do a flat sequence here. And so we will start there, and then I will add a frame after. And I'll stretch that a little bit. Oops. And then I will add a frame after that. Okay, so now what does this sequence thing do? Well, each time the loop executes, whatever we want to happen first will happen in this block here. Whatever we want to happen second will happen here, and whatever we want to happen third will happen over here. Okay, so what do we want to have happen? Well, we want a light to flash for half a second, indicating that the answer is coming up. So let's go ahead and drag that in there, and we'll put our answer coming up and create a constant there that says true. So let's, and we need to change that to 500. Okay, and it's supposed to do that just before the thing changes. So if we take and put our other pieces of this up here, we can probably get that to do something good. So let's put the pieces in there somewhat like that. We could put them all in one frame, but I'm going to drag this one back to this frame. Oh, the line's broken, but if I just simply connect it there, that looks good. And so let me click on that and Command U, see if that makes things behave themselves a little bit better. Okay, that's looking a bit better. And I can adjust the while loop as well in a minute. Well, this almost works, and if I take and run it, you'll see that the answer coming up thing does go on, but it never goes off. So we have to find some way to turn it off. Okay, this becomes where things get a little bit interesting. We need to wire things to our indicator here, but we need to control the state in two other places in our loop. So the secret to this is something called a local variable, and we will look and see if we can find where that is. And if we look under create here, we will see a local variable. Okay, so let's click on local variable, and we will put a local variable here, and this we want to set to constant, and we will change that to false. So now let's see if it works more or less the way that we want. Okay, we'll wait a little bit and see if when the loop executes. We'll wait and see. It's still not quite working right. So maybe we need to turn it off one more time. So let's just create another local variable. We'll stick it here, and we'll create another local constant that we will set to false. And let's see on our block diagram if that will help us out. Okay, it doesn't seem to be doing very much. Well, that's because we don't have anything in here to control the time. So let's drag one of those over. Again, that's a control drag, and let's see if it works now. Okay, and it blinks on and off, and since we have it set like that, that seems to be fine. I think the last thing we need to do is edit that to be 4500. Okay, so now if we run this, and we can change this to FF, for example. We'll wait, and we'll say answer coming up, and then it changes. Okay, so it accomplishes essentially everything that we wanted to recap, and it takes a long time to turn off because it has to go through a complete loop before it does. I'm going to do my Command U so that I can get everything to fit very nicely in there. And there we have the completed loop. The idea is we have a sequence structure. So the first thing we do is turn the LED off, wait 4.5 seconds, then flash the LED for half a second and read our input, and then we convert our input to the binary values and turn the LED back off, and then the loop repeats.